We wanted to explore the academic literature and the history of music theory, together with computational tools that can be used to visualize information and tools used to design interactive virtual environments.
The visual music project our team worked on improved our understanding of how both music and visuals interact. We also were able to employ the music theories to create notes that can interact with the graphics. Our main goal was to create an environment which is user-friendly and at the same time can enhance the experience of the audience while they are using the environment. The graphics that we created has its role to deliver the messages that we were looking to deliver from the level, the gates, the tea house, all the way to the trees and the avatar, which will introduce the audience to the environment and make them able to visualize the music.
We hope to create an experience where people can gain an intuitive understanding about the structure of music by exploring an interactive musical environment where sounds and visual objects are related.
Our project utilizes the Unity game engine. Some of our group has had experience with other engines, but we've found Unity to be very intuitive. Building environments is straightforward, and adding scripts to define the behaviors of in-game objects is relatively simple. There's also a wealth of free, prefabricated assets for amateurs like ourselves to use, but our group tried to mostly create custom assets like the tea house that you see here. The other primary reason for our use of Unity is its ability to integrate with the programming language Chuck. Chuck is, in our humble opinion, the programming language for sound synthesis and music creation. In Chuck, you can control when the sound plays and for how long down to the sample, of which there are 44,100 in a second.
"3ds Max is a software modeling tool used to build and animate 3D computer assets. When you want a virtual object and you can't just download it from the internet, you can build and animate it here and then use it in Unity. The reason we build it here instead of Unity is because 3ds Max has tools that make shaping boxes as easy as molding clay, as opposed to Unity, where modeling is more like molding dried clay with glue sticks. This is just one of many 3D models we've built in 3ds Max. Anything you see in Unity was built here, then transferred over there. Level building is where the magic happens. You take all the components and glue them together to build an interactive world. If we didn't have any interactions, the user would be like a ghost, floating through walls and only able to observe the scenery. And that wouldn't make a very fun experience, so Unity's job is to bring this playset to life. Once we finish building the musical application, we would like to make it available for anyone to use.
This is an example of a scenario where a player gets visual feedback when selecting two notes that have frequencies that make a mathematically simple ratio when compared, and also have a pleasing quality of consonants when they are heard at the same time.
When an instrument plays a note, the pitch you perceive is the fundamental frequency of that note. However, the waveform that defines the sound that you hear is much more complex than a simple sinusoidal curve. To make complex sounds, we can start with the fundamental frequency and layer other frequencies, called overtones, on top of it. Overtone frequencies are integer multiples of the fundamental frequency. So the first overtone of some sound is a frequency twice that of the fundamental frequency, or the pitch you perceive. The second overtone is 3 times the frequency of the fundamental, and so on. We took that model and created a synthesizer in Chuck that allows us to build complex sounds. With this Chuck script, we can see what it's like to take a simple sine wave, add some overtones, add vibrato, and change its frequency. Tunity is the aptly named Chuck plugin for Unity. It allows us to run Chuck code like our synthesizer in the C# scripts attached to the objects in the environment we've created. This simple example shows how that same sound we just created in Chuck can be played when a user clicks on these blocks. Each block has its own frequency, and here, when a user clicks on 2 notes, if both notes belong to the same major scale, the remaining notes of that scale are highlighted in blue. The goal of our project is not only to create a way for people to produce music, but also to provide an educational tool.